I'm just having my lunch.
Just to let you know, I'm just recording this one in YouTube.
I'll come back in 5 minutes.
Hello.
I'll come
Yes,
back in 5 minutes.
Mr. Gupta, you need to switch on your video.
Yeah, just a minute.
Just switching your video.
Just a minute. Yeah, switch on the video.
Is it live on YouTube?
We are recording this
Yeah.
on YouTube right now.
Yeah.
So that later on after this seminar, you can watch this one. The link, I will share it.
Link will send through the chat.
Yeah.
Mr. Gupta.
Yeah. Yeah. Video on हुआ? Video on क्या?
हाँ, वीडियो ऑन है आपका.
Right. I could see now.
The class attendees link is on.
Hello.
What are you
Start with your this thing. What to do and what. Amit,
Huh.
you start with your this thing. You are supposed to give a what to do and what not.
Okay.
That you start.
Okay.
Now, when you will start?
Just now. Just
Just
Sorry?
wait for a couple of seconds. Let it be 4 p.m.
Attendees ওরা মানে already ঢুকতে আরম্ভ করেছে?
Yeah, we have a few attendees here.
Okay.
We have total 18 participants now.
8 attendees.
18.
Oh, Arnav, there are some people asking about what is the password, from IIM. Like Mr. Ashok Datta was asking, I did not need any password. I just clicked it and it came. But is there any password?
No. If the click is there, if this link is there, then there is no password is required.
Okay. But Ashok Datta was asking, so probably is he joined? Ashok Datta, there are some people from IIM, they're supposed to join.
Normally, it's not required to have any password for attendees. They can directly register and join.
Okay, then I'll tell him.
But there is a webinar ID and passcode. If you do not have the link, then you have to provide that webinar ID passcode.
Okay. That I think Arnav, you have already communicated to them, isn't it?
Yes.
Yeah.
Fine.
Amit, start.
Okay. Yeah. So welcome everyone in this seminar. Hello. And it gives me an immense pleasure to be a technical host of this online power seminar. We have esteemed panelists here. Each panelist will be given 10 minutes, and with exceptions of a couple of panelists. And after this 10 minutes, we will be having a buzzer sound so that it will be understood that need to wrap up the speech. All the panelists are requested to have their video switched on If there is any break, that's an exception. And during the speech, it is requested like other panelists should mute their speakers so that unnecessary interference can be eliminated. And for the attendees, if you have any questions during the ongoing webinar, you can raise your questions in Q&A. Q&A button you can find down below in your Zoom application. So you can write that particular query to a specific panelist or to all panelists. Whoever is free, they can reply you back, or else we can take that query to the end of the seminar. Thank you. I would now request the moderator, Arnabda, to start this webinar.
Thank you, Amit. And good afternoon, everybody. Myself, Arnab Banerjee. I am the Director of Steel Tech. On behalf of GBS Energy Private Limited, we warmly welcome all for attending this power seminar. The topic of the seminar is Renewable Energy Mission for Industries and Renewable Captive Power Plant at cost-effective rate for steel, foundry, and heavy engineering industry. Now, I should give you the total seminar program, who are the speakers and who will speak in this seminar. The seminar program starts with the introduction by the organizer, Mr. Amitabh Ghosh. Mr. Amitabh Ghosh was ex-Senior Vice President Texmaco, and now he is the Director of GBS Energy Private Limited. It will be followed by Mr. Niranjan Saha, who is also a Director of GBS Energy Private Limited, and he was Director Project of WBPDCL. After their introductory talk, the keynote address speaker will be Dr. S.P. Ganchaudhuri. Dr. S.P. Ganchaudhuri is a renowned personality in solar industry. He is called the Solar Man of India. He is Director NBIIT and ex-Director of WBREDA. After the keynote address is over, it will be Mr. Pritish Kumar Sen. Mr. Pritish Sen is the head of Institute for Steel Development and Growth, and he was in Tata Steel for a very long period of time. After Mr. Pritish Sen, the next speaker will be Mr. Ravikant. Mr. Ravikant has a long years of experience in power industry, and both conventional and renewable energy, serving NTPC and Adani. Presently is with Adani Green Power. After the speech of Mr. Ravikant, the next speaker will be Mr. Amitabh Ghosh, Mr. S.K. Gupta. Mr. S.K. Gupta is the Managing Director of Crane Manufacturing India Limited and Crane Solar. After Mr. Gupta, next speaker will be Mr. Amitabh Ghosh, GBS, Director of GBS Energy Private Limited. The next speaker will be Dr. Nishit Ranjan Mandal. He is the ex-professor and head of the Department of Ocean Engineering and Naval Architecture in IIT Kharagpur. After Dr. Mandal, the next speaker will be Mr. Devabrata De. He was ex-ED WBPDCL. After Mr. Devabrata De, we will have an interactive session, and you can raise your questions to respective speakers on their topics. And finally, the vote of thanks will be given by Mr. Shubhiranjan Ghosh, who was ex-head plant and projects Haldia Petrochemicals Limited. Thank you. Now I hand over to Mr. Amitabh Ghosh for his introductory lecture.
Thank you. Good afternoon, everybody. Again, on behalf of GBS Energy Private Limited, we warmly welcome all for attending this power seminar. Title: Renewable Energy Mission for Industries, renewable captive power plant at cost-effective rate for steel, foundry, and heavy engineering industry. Last year, on 9th August, we organized a power seminar on renewable energy vis-a-vis conventional power at ITC Sonar Hotel, Kolkata. Subsequently, we made arrangements to organize another power seminar on 24th April this year at Park Hotel. However, due to unprecedented coronavirus crisis, we were not in a position to organize the same. But to continue our initiative, we are now presenting another online power seminar today. Briefly, we would like to present the subject. The conference objectives of details are as below. Power is the raw material for steel, foundry, and heavy engineering industry, particularly where furnace is part of the process. Presently, power is generally sourced from two options, either grid or captive, both basically fossil fuel power. This power from above sources are very costly. It's costing about 7 to 9 rupees per unit. Therefore, the electricity bill for said industry consumers are very high and have considerable effect of cost on finished product. I can give you an example. For Texmaco, the electricity bill per month is in the tune of 3 crores. They are having foundry, and for foundry itself is near about 2 crores. So generally, the requirement of power of this type of industry is up to around 25 megawatts. Now, in order to overcome this high power cost issue, industry consumers can invest and set up renewable power plants at any suitable location and draw power through wheeling to their industry units following one country, one grid initiative. Renewable power may be rooftop power, ground-mounted power, small hydro, wind, biomass, or through any other suitable mode. Out of all means, solar is the fastest mode of power generation and most favorable for this objective. The government and the private sector install solar parks with requisite grid connection that is the best suitable for appropriate renewable energy sources. Takeover of existing solar plant or hydro plant is also a solution. Power cost at industry through this modality should be around 4 rupees per unit, which is a big saving. And surplus power also can be given sold to grid as per PPA. This payback period for this is around 5 years, and thereafter free power is available for at least 20 years. So following this renewable energy vis-a-vis conventional fossil fuel power, this will allow the following advantage: less pollution, green power, and also investor for industries will use or invest for renewable energy, and then reduction of energy cost will reduce product cost and it will make the product more competitive. So this is finally a win-win situation for renewable power and industry sector. With active participation, cooperation, and regular awareness program between stakeholders, it will be possible to support Indian heavy engineering industries of around 25,000 crores with cost-effective solutions. And also, it will be possible to upgrade renewable energy in line with government targeted figure of 175 gigawatt by 2022. Furthermore, the aforesaid initiative of Renewable Energy Mission for Industries will enable us to follow the guidelines of UNDP, that is United Nations Development Program, and IRENA, that is International Renewable Energy Agency, who have separately set up goals to meet 75% of total industrial energy demand of energy intensive sectors to be made from renewable energy options by 2030. So this is what I wanted to start. I would now like to hand over to my colleague, Mr. Niranjan.
Good afternoon, everybody. Mr. Amitabh Ghosh have already mentioned about the seminar organized by our company on 9th August 2019 on renewable energy vis-a-vis conventional power, challenges, opportunities, and roadmap. That seminar was successful due to the very good response and active participation of experts from NHPC, DVC, WPDCL, CSC, and other reputed companies dealing with power and other field of industry. In the present pandemic situation, we have decided to organize this webinar today. In this webinar, our main object will be to discuss about how the renewable energy sources like hydel, solar, and wind power can be utilized as captive power in steel and heavy industry. We all know that there are some pros and cons in each type of renewable energy sources. All renewable power generation are from clean sources of energy. But in case of hydel power, the project cost is very high, which is about 10 crore per megawatt. And the gestation period of the project is also very high. Moreover, the PLF of hydro plant is not very good. Hydro plant location may be far away from the factory. For this, the wheeling cost of the power will be more. In case of solar plant, land requirement is high, which is about 4 to 5 acres per megawatt. And mainly the power is generated in daytime, and it will be available for 5 to 6 hours. If solar power is required for 24 hours, the capacity of the solar plant should be increased at least 3 times with proper storage facilities. Solar power will not also be available during monsoon time. In case of wind power, the onshore wind power installation cost is about 6 crore per megawatt, and offshore wind power installed capacity is about 8 crore per megawatt. Similar to solar power, wind power is also intermittent. The wind turbines are reliant on weather and therefore are not capable for generating power for 24 hours. Moreover, steel and other heavy industries need reliable power for 24 hours. So in spite of their captive power, they should be connected with the grid to get power whenever they need, and particularly in case of any emergency. For this, they have to pay maximum demand charges to the power supply utilities, whether they draw power or not. I will request our expert panelists to explain and suggest what should be the best option for selecting the renewable power sources to be used for the captive plant by steel and foundry and other heavy industries. Thank you all. Now I hand over it to Arnav to proceed further.
Thank you, Mr. Shah, for your useful information. Now I request that Dr. S.P. Ganchaudhary to start his keynote address. Before that, I would once again like to speak that Mr. Dr. Ganchaudhary is a renowned personality in solar industry. He is called the Solar Man of India. He is the director of NBIRT and ex-director of WBREDA. Over to Dr. Ganchaudhary. Please start your keynote address.
Thank you very much. I have a small presentation. Can you share your screen?
Yes, Mr. Chaudhary. There is a button over there called share screen. You can click on that and you can start sharing your screen.
It is written that host has disabled the share screen option.
I have this with me. This is on, I think. From here it's on. Do you want to? Do you mind if I can send? If you can send me the screen, whatever file it is, I can start sharing it.
Screenshot.
In which mail ID should I send you?
It's info@amitecindia.com.
Can you write it in the chat box, please?
Yes.
That you can share your views and ideas in the meantime.
By the way, I think Mr. Chaudhary, if you can try once again, it should work for you. Yeah. Mr. Chaudhary, you are mute at the moment. Mr. Chaudhary, I have granted you the permission to share.
Amit, please help him. Please help him to unmute.
Now, I have unmuted him. He has to accept also.
Okay.
Yeah, you are sharing your screen, Mr. Chaudhary.
Can you see?
Yes, we can see your screen.
Yes, it is coming. Yes.
Okay. So thank you very much. Thank you for organizing such a nice webinar. Very important topic. Captive power, plant for the industries, heavy industries. So I will make a short presentation because your time is very small, very short time. So let me make a small presentation. Next one. In India, for the past few years, the shift to clean renewable energy has been a priority. The growing environmental awareness and reduction in prices of green energy has fueled this trend. Really, the renewable energy, as it was mentioned, there are many forms of renewable energy: solar power, wind power. Next one. Biomass power, mini and micro hydro. All these things, falls under the category of renewable. And in India, in recent past, we have given a lot of importance to renewable energy program. Particularly, Government of India has announced some target also. I'm coming to that. So out of this this biomass, you can see the mini hydro, mini micro hydro, solar power and wind power. As it was pointed out that solar is the most popular and most effective renewable energy program for the industries also. I'm coming to that. Now, next one. India's renewable energy ambitions are most aggregate in the world, are very aggressive in the whole world. The short-term target of 175 gigawatt renewable energy by 2022. We have achieved up to now about 85,000 megawatt of RE power. 85,000 megawatt we have already achieved. We have to achieve 175 gigawatt. That means 1,75,000 megawatt we have to achieve by the year 2022. Long way to go. We are only in the halfway. So we have got only 1.5 year time. So we have to do a lot in this sector. And Prime Minister has announced that 450 gigawatt of solar power or renewable power has to be completed by the year 2030 to keep our commitment towards emission reduction. He announced this in the New York Convention, where India has targeted 450 gigawatt of renewable power by the year 2030. So obviously it's a huge target. It is a huge target. Now Indian renewable energy program can be divided into two categories, grid connected and off grid. I'm not talking about off grid here, but let me discuss about the grid connected program. 85,000 megawatt grid connected RE power plants, as I have mentioned, have been installed in the country, and millions of off grid systems are also working in the country. Next. What is a captive power plant? Now I'm coming to captive power plant. Now, captive power plant, according to me, also called auto producer or embedded generation, is an electricity generation facility used and managed by an industrial or commercial energy user for their own energy consumption. Now, India's installed capacity as of now, you know, it is about 373 gigawatt now. Out of this installed capacity of captive power plant, we do have a lot of captive power plant, but mostly thermal captive power plant and little bit renewable. Installed capacity is about 83 gigawatt, which is quite significant, 83 gigawatt. But the contribution of RE in the captive power generation in India is very insignificant up to now, but it has a lot of potential, and days are coming when the industries should go for captive power because the thermal power generation is becoming costly day by day, and it will be very difficult for the industries to take permission for installation of thermal power plant as captive power plant in industries. Finally, they will be insistent on putting up of renewable power, renewable energy power for as captive installation. Next one. India's target for renewable power, as I have mentioned, 175 gigawatt, 100 gigawatt is solar, wind 50 gigawatt, biomass, small hydropower 25 gigawatt. And India's commitment towards reduction of emission by the year 2030 is 33%, base year 2005. We have to do that. So all the government regulation, rules and regulations will be directed towards protection of the environment, towards reduction of the emission. So industry should be ready to absorb such type of regulation. That is my worry. The industries, they are thinking it will go in the same way, but they can't go in the same way because the Indian regulations are coming in a different stringent manner, so that industry should also go for renewable power generation as their captive power generation. Let us now see what are the opportunities for captive generation by the industries. Next one. There is huge opportunity to set up captive RE-based power plant in India. The potential of RE-based power plant in India by the industries as captive power plant is 100 gigawatt by the year 2030. It was assessed by a Pune-based group that in India 100 gigawatt of RE-based captive power plant could be installed by the year 2030. So it is huge opportunity. In next 10 years time, we can go for 100 gigawatt captive power plant, only RE-based captive power plant. India's target of RE is 450 gigawatt, as I have already mentioned. Next one. Out of many forms of renewable energy, solar energy appears to be most attractive as captive power plant. Captive solar power plant may be rooftop or land-based. You know, most of the industries, in fact, I have also, contributed to many of the industries for setting up a captive power plant in Calcutta-based. Some industries, they have already put up megawatt scale captive power plant here in Kharagpur, in Kharagpur and nearby in Midnapur district. They have put up 2 megawatt power plants. UL, a company. So a lot of captive power plants have already been installed. Captive power plants of 7 megawatt solar has been installed in Durgapur area. So now captive power plants are coming up, but the captive power plant, solar power plant, could be of two types. One is land-based, one is rooftop. Now land-based, the captive power plant, solar power plant needs land. Obviously, it needs land, and the land cost, as you know, land cost is high inside the factory campus. If it is very cheap, then it doesn't matter. But generally in the factory campus, if you put up land-based solar power plant, it will be expensive and you'll be losing a lot of land. You have to spare a lot of land. So in that context, rooftop solar power plant is much more economic, and potential of rooftop solar power plant in only West Bengal is about 700 megawatt. Only in West Bengal industries, rooftop, over the shed, on the roof shed, if they put up all the rooftop solar power plant, the potential is about 700 megawatt, which is huge. So I think rooftop solar power plant could be a good idea for the industries. But nevertheless, land-based also they can go. They can purchase land in a remote area where land cost is very cheap, and then will the power up to their factory, up to their industry, as by using the national grid, and they can also use the solar power as captive power, and the surplus power they can sell also into the grid. So both the options are there, rooftop and land-based. Now, in some next one. Recently, floating solar power plants are also becoming popular as a captive power plant. Many industries, they have got water body inside. In Sagar Digi, power plant, they have got water body inside Sagar Digi power plant, and they have set up a 5 megawatt floating solar power plant in the Sagar Digi area. So, in any industry can, in order to avoid land, they can put up, if they have got water bodies inside their industrial campus, inside their premises, they can go for floating solar power plant, which the technology is now pretty mature. And we have put up the first floating solar power plant in Kolkata near Salt Lake New Town area in a water body. We have put it up. So similarly, the industries can put up floating solar power plant as captive solar power plant. So there are three options: floating solar power plant, land-based solar power plant, and also rooftop solar power plant. So industries may consider these three opportunities are there. Next one. Rooftop captive solar power plants are more viable. The cost-wise also it is okay, about 3 to 3.5 crores. Now 3.5 crores per megawatt cost has come down. We need about 4 acres of land to set up 1 megawatt captive solar power plant. Those industries, as I mentioned, having water bodies inside factory premises, may go for floating solar power plant. However, industries may set up captive power plant in some areas where land is very cheap. Some industries, they have already purchased land in Purulia district, and they are using, they have put up solar power plant there, and they are using that solar power through the captive, by wheeling, and they are using that same power for their own consumption. It was mentioned that the payback period of solar power plant, both rooftop and land-based, or even the floating solar, all are about, it ranges from 4 to 5 years. Life of the plant is 25 years. So it is very lucrative, and the cost of generation has come down now. A lot of cost has come down, and cost is very insignificant. Now the cost varies in 3 rupees, range of 3 rupees, 50 paisa, something like that. Next one. Now regulations, net metering is allowed for the now industries who have set up in Calcutta, in West Bengal, the industries who have set up the solar rooftop power plant for their captive use. They are using is under net metering mode, and they have indicated that their generation is quite good, and they are getting a lot of benefits from the rooftop solar power plant. In some states, it is gross metering, for which a separate PPA needs to be signed. In case it is not net metering, if it is gross metering, then the DISCOM will purchase your power from the company at a predetermined rate, and you need to sign a PPA, and it will be adjusted. Net metering is more attractive. Wheeling and banking is allowed under the regulation. Even third-party sale is allowed in some states. And of course, there are some conditions. All ERCs are now framing new regulation to encourage, installation of more solar power plant by the private companies. So in next 2 to 3 years time, we will find more private companies are putting up, rooftop solar power plant or captive solar power plant as an alternative to their thermal power plant and diesel-based power plant, where the cost of energy is very expensive. Financing, soft loans are available from financial institutions, banks, Power Finance Corporation, IRIDA, all the banks are now financing. The projects are financially viable, the rooftop solar projects. I'm just concentrating on solar power because in West Bengal, the wind power potential is very low. I should mention to you. So wind power potential is practically insignificant in West Bengal. So the West Bengal industries can't go for any wind power plant as a captive power plant. There is a potential, little bit potential of small hydropower plant in North Bengal, but most of the potentials have been tapped. And some industries, there are about 4 industries now, they are putting up 6 to 10 megawatt hydropower plant, small hydropower plant as captive power plant. There are, I think there are 3 or 4 more vacant sites where the about 10 megawatt range, small hydropower plants could be installed by the industries. So the limitation, the wind power, small hydropower is potential is limited. That is why I am just concentrating on solar power, which has huge opportunity in the state of West Bengal. Even RBI, Reserve Bank, has allowed a number of incentives for RE-based financing, RE-based power plants in this throughout the country. So the financing mechanism is also available. Regulation is there. The cost has come down. Next one. Cost has come down. The cost has come down. The regulations are coming. The regulations are favorable now, and also under the revised Electricity Act, the stringent rules are coming for the industries to go for mandatory going for the captive power plant on renewable energy mode or renewable energy route. So under that circumstances, I would urge to all the industries that time has come when you have to switch over from thermal power plant based, captive power plant to renewable energy. And out of renewable energy, many forms, solar rooftop will be best alternative. If you have your roof space, otherwise, if you have your water body, you can go for floating solar power plant. And if you have land, available land in any place, anywhere in India, you can put up the solar power plant there and use it as a captive power plant through wheeling and banking. So my point is, as an industry, not only you will be commercially benefited, but you will be also contributing to the country's commitment for reduction of emission by 33%, as I have mentioned, by 30% by the year 2033, by going for this type of captive renewable energy based captive power plants. So that is the thing I thought I should share with you, and I should thank again to you for organizing such a nice webinar for the industries, and thank you very much for giving me opportunity. And I would again request all the industries to think very seriously to switch over to renewable energy based captive power plant to protect the mother earth and also to reduce their commercial costs. Thank you very much once again. Thank you.
Thank you, Dr. Chaudhary, for your excellent speech. I am sure the participants have got very rich experience out of it, and I now request Pritish Kumar Sen, who is head Institute of Steel Development and Growth, to take over and start his speech.
Yeah, thank you, Arnav. Thank you, Arnav. Am I audible?
Yes,
thank
you
you,
are totally audible.
Mr. Pritish, you are audible, loud and clear. Just a quick announcement. There are a few questions lined there in Q&A sections. I just request to the panelists, if you are free or have some time, please reply those queries. Mr. Pritish, you can please start. Thanks you.
Yeah. Thank you, Amit. Thank you, Arnav. And good afternoon, everybody. And it's a pleasure to talk to you today. At the outset, I take this opportunity to congratulate GBS Energy for organizing this webinar on this power seminar covering the renewable. And Dr. Chaudhary has very much explained what is the importance of it. And that is not only relevant for India, but for throughout the world. I thank again Mr. Ghosh and GBS Energy for inviting me for this webinar and share my views. I shall keep my views very briefly. As the time allotted is 10 minutes, I'll try to cover within that. As we all know, energy is a very basic requirement of human being of today's world. It has become so inevitable that we cannot think without it for a moment itself. Even for this webinar, what it is organized, if the power is not there, we cannot connect ourselves. Anywhere in the world now, people are connecting, and that's the beauty of it, and the energy, the basic one which is being used. So we need energy almost for everything, from our comfort to health, to connectivity, entertainment, and all you can think of the energy is required for that. As per the International Energy Agency, the global energy outlook, it says that this need for energy will keep on increasing, and by another 20 years, we need around 30% more of energy what we have been doing, and mostly it is from requirement further is from developing countries. So over the years, decades of decades, we have used the fossil fuel and generate as much as energy we wanted and developed our industries, fulfill our domestic needs, requirements, and kept on increasing as the country progresses. And there is an increase in per capita income, that is increase in energy demand. But we did not very much bother about the pollution we created. But there is a concern because the alarm bell has already ring. And if you do not take care now, then existence of human being may be a problem. So therefore, there is a lot of concern among the people around the world, and we are working for alternate source of energy, particularly renewable and clean energy. The matter has been very much well covered by Mr. Ghosh, Mr. Saha, and Dr. Ganchaudhari's excellent lecture, which gives what is the importance he has been also harping on. The industry should also work for this renewable energy. As I am from steel industry, let me cover very briefly the relationship between the steel and energy, and also the concern of the environment for the steel industry itself. So steel was, is, and will be very critical for energy sector, whether it is fossil-based, nuclear power plant, new renewable sources, wind, solar, geothermal, anything you can think of. Whatever is the source, steel is very crucial role to play, either producing or distributing energy and or improving the efficiency of that. Because steel is a very versatile material, as you all know, it's very strong, durable, precise, stable, endlessly recyclable, cost efficient and safe. So to cover a few, that solar energy, what Dr. Ganchaudhary talked about, key is also the steel requirement is there, because we need for the solar thermal panels, pumps, tanks, heat exchanger, we need steel very much over there. If you talk about the wave and tidal, the steel is the pile, the main component of tidal turbine. In the tidal energy system, steel is also very much used for fabricate wave energy devices and so on and so forth. So if you talk about hydraulic, there also steel is used because steel is used in reinforced concrete. If you talk about very much used material onshore, offshore turbines, almost every component of wind turbine is made of steel, from foundation to the tower, gears, casings, etc. For biomass also, that we use extensively tool for agriculture. And for nuclear and fossil-based fuel, you can also know for mining, whether it's offshore platform, oil platform, equipment for oil, gas extraction, production, pipelines, distribution, natural gas or oil, storage tanks, power plants, everywhere it is used. So having said that, what was like has been, let me talk about how much steel we are using. We are around the world, we are using around 780 million tons of steel for every year, and the demand is on the rise. And as you know, it is almost the 40 times more than the next metal used, that is aluminum. And because there are many advantages of steel, the cost to steel ratio is cost to strength ratio, this is the cheapest. But at the moment we are selling the steel almost at the price of the onion selling per kg. But anything increase on that, people say steel is costly. But actually it is billions of dollars have been spent on the mining, on the sector of your plants. And also now the very much concerned is this environment. So therefore, there is a need of steel is growing. It will grow, and next 30 years, maybe it will be double from the time what you are using now. And there are two major routes what the steel used for. One is BF, as you all know, blast furnace and basic oxygen furnace. Another is DRI and electric arc furnace route. The concern for this industry, for the environment, is that it's a polluting industry. You know, for every ton of steel we produce around 1.8 to 2.2, average is around say 2.0, you can say, ton of carbon dioxide you emit. So this is a very, very polluting in the industry. And if you see around the world, what total out of the total carbon emission, 7% of it, around 2.4 million is by the steel industry itself. So therefore, it's a very dirty and polluting industry, it is known. But what is the reason for it? If you see, it is a BF route, that blast furnace route. The carbon which is used not only for the energy, but it is used for the reductant itself. So it's a basic need for that, if you go for a, BF blast furnace route. So what is the one which will, how do you do it? One is to use coal, but use the, capture the carbon and utilize again in different processes. That is possible. Technology is available, not in a big scale, but the people are working onto it. But for all these things, you need cost. You need like almost, you spend around $150 per ton more than what it is the cost of the steel now. The question is, who will pay for it? Whether it will be by the government or it will compensate by our customers. And that is the question there, but definitely people are concerned and worry about it. The next, how to do is the hydrogen. Hydrogen is also a reductant. People have done a lot of work into it, and it is a very good source. But how to generate that hydrogen? That hydrogen, if you generate by using, like again, fossil fuel, then you are not doing this thing. So therefore, a lot of work is going on. The people are using the renewable energy to generate hydrogen, use the hydrogen as a reductant, then use arc furnaces. That arc furnaces again used by renewable energy, that is solar power or wind power. And people are very much concerned and working for it. So if you see that there are technologies available, not to the scale, but the work is on. But when we generate steel through hydrogen, that is again that another word you must have heard of, the green hydrogen. That means the hydrogen is produced through renewable energy. People are working into it, and they say that this is CN, they're carbon neutral by the time 2050. These people are concerning, they're signing. It's a multi-generation commitment. So therefore, the people who are signing it, they are also concerned. They are also worried. They also not that, like, suppose you sign something for the 2050, it is not that you start working in 2040, you have to start working right from now. There are many people, many group of companies who are mentioning that they started work into it. One is GFG Group, Liberty. I say that they're in South Australia. They are putting up a solar plant, which is of 280 megawatt. And they are spending about $1 billion into it. They say that with the renewable energy, it will go to 3 gigawatt. Gradually, they increase it to 3 gigawatt, having this renewable like solar mainly, and then wind as well. And from that energy, they will use it for doing the hydrogen through electrolysis, and use that hydrogen once you use, for reduction, that byproduct, the waste, what it is now CO2 for, for using coal, that will be water. So therefore, it's very clean. And it will, from the dirtiest industry, so steel side will try to go for a very clean energy. So steel necessary and essential aspects of the society, and the global demand is growing. But the moment the invention of rebuilding the new image of the steel requirement is there. So building a sector that will sustainable, not just financially, but ecologically, and providing quality jobs for attracted to a new generation. And most importantly, is the societal needs. Society needs metal, but to produce without any pollution. So climate change is the key accelerator for the steel sector, forcing it to reinvent, and ultimately, according to the climate change, what will save us. So the example what I given is that Liberty Steel is doing 280 megawatt solar plant near South Australia. which will expand to 3 gigawatt and largest solar in the world. So what to do about it? For this, we need a lot of investment, and 3 things which are very important is the consolidation, collaboration, and the right policy framework. So for this thing, a lot of investment is required. The government also should come out. That customer also should be willing to put. There will be scale to lower the cost, compete globally, and critically it enables the large solar investment in technology, and the people are working into it. So also the collaboration, partnership is required. Very much we know what is the R&D, what lessons we have already learned from the, the automobile industry. They also join together. And so also that what is the cooperation between that Ford and Volkswagen, JLR and BMW, they are working together. Now the time has come for the working for getting the technology and reducing the cost. The policy, of course, will be very much important. That is the one the government should come out and see and help how to do it. And ultimately, only one thing which will be going to take our sector safe, it is our invention and investment in the new technology to eliminate this carbon pollution. As you know, many places the children are, protesting for the heavy industries because it is polluting and it is killing. So there are energy, they are very angry, and they are protesting on the street also around the world. So we need to reinvent and change the industry that becomes very clean industry. So I am sure with this type of webinar, we'll create awareness, we'll share knowledge to make this clean change much faster. Thank you very much. I think I covered within the time. Thank you.
Mr. Arnab, you need to unmute yourself.
Thank you, Mr. Sen, for your very valuable speech. And now your lecture was related to steel. Being a steel man, I can also correlate the same. So now our next panelist is Mr. Ravikant, who is Associate Vice President, Adani Green Power. Over to Mr. Ravikant, please. Please unmute yourself, Mr. Ravikant.
Hello.
Am I audible now?
Yes, you can speak now.
Yeah. Thank you, gentlemen. It is an honor for me to be part of this seminar. And in fact, Mr. Day had requested me to be part of it, and I'm very thankful to him. I'm honored to be a part of the renowned panelists out here. So I will briefly give my views with respect to the captive power plants and what are the alternatives with respect to that is how we can really bring down the cost. The way we understand and the way it is so far within the captive power plant, generally the industries which are with respect to a steel industry, large industrial installations, it can be a cement industry, it can be maybe a data center. In fact, data centers are new in this country, and each and everybody requires a large amount of power. The data centers are power guzzlers. Now, in case they have to take the power as it is from the grid, it is quite expensive. In case there is provision with respect to green power, wherein the carbon emissions can be reduced, yes, definitely we should look into it. And that is exactly what is now being done. We have large offices which requires power. We have data centers and the industrial facilities. So generally, in case we go in for a captive power plant, it can be that is a thermal power plant or a gas-based power plant. The cost of the power which is there, it is going to be something like 4 rupees and 5 rupees per unit. And the cost of development of the facility is going to be something like 5 crores per megawatt or even around 6 crores per megawatt, depending on the location. Now, looking into all these aspects, there is a possibility that we can really look into a renewable power, which can be done very quickly. There is going to be very less gestation period. There are going to be risks involved also with respect to a captive power plant of thermal and gas. The risk in the sense the capital which you are going to invest in this particular captive power plant, which is thermal or gas, it is quite phenomenal. And the core competency of that particular industry is not of generating the power, but of doing something different. It can be an IT industry, it can be a steel industry, it can be any industry. Further to that, they have to maintain that particular asset. And for maintaining, they require highly qualified professionals. So this becomes a truly a separate, that is a vertical which they will need to handle. Out here, we have a provision now wherein we can go in for green power. And the green power, as it stands today, it is more viable in respect of the cost and with respect to the gestation period, which can be very, very less. And when we talk of renewable power, it can be solar, it can be wind, but generally it would be solar because the wind, that is wind speeds available in the country is not there everywhere. So when we are talking of solar, we have provisions with respect to, like Professor Gan Chaudhary had told, a rooftop solar or a ground mounted solar. But there are some limitations with respect to rooftop, in the sense that the capacity in the rooftop solar is going to be in kilowatts only. It cannot be in megawatt. The reason is that the limitation of the area. The area requirement for a solar for 1 megawatt would be something like 4.5 acres of land. So now that much of land is not possible to get for the rooftop. So obviously it has to be ground mounted. When I say 4.5 acres per megawatt, this is for a tracker system. We have got another system, what is known as a fixed tilt system, wherein the panels are facing the south and it continues to be continues to be facing the sun continuously. In a tracker system, the panels are going to move along with the sun, and then we are going to get more generation. So, however, the area requirement is more. So the efficiency of a tracker system is higher as compared to the fixed tilt. Now, when we look into this particular aspect, that is the power generation from the solar, we will have issues with respect to the requirements in the night. Since at night we are not going to have this power, so necessarily we have to have grid supply also. However, because of the captive power, definitely a lot of load demand is going to be reduced, and because of that, your cost of the power which is required for the industry is going to come down. So this particular look into the captive power plant is definitely very, very that is captive with respect to solar is definitely going to be beneficial. And even the billing which is done, like we have something what is known as an open access. So when there is an open access as per the electricity policy, one can have an industry at a particular location, let us say West Bengal. And then in case you want to have a power plant, maybe in Orissa, even that is also possible in the open access. So you can put it anywhere, wherever land is available. And from there, you can put it in the grid, and then you can get the power into that particular unit. And here the billing is going to be such that there is not going to be what is known as the cross subsidy is going to be reduced. If you see the billing, there is always a cross subsidy which is added. And like this, in the which are already there, the cost is going to come down for the industry. So this particular aspect is absolutely very, very essential. Now, further to that, in case for any reason there is going to be excess power from your captive solar, let us say your industry has shut down for maintenance, or there is no requirement for a set number of days. In that particular case, you can definitely do net metering, and you can give it to the discoms, and they will pay for it. So there are provisions in the policies wherein that is no power is going to be wasted. So this is the benefit which is there. And in this particular case as such, in case we take a comparison with respect to the thermal power or a gas-based power, now the ramping up is also very, very difficult. It is not possible that you can straight away ramp it. Whereas out here, since it is going to generate a particular the power at a particular pace, so there is no issue with respect to that. And you know exactly when the power, what sort of a power you are going to get it. and excess power you can always set it aside. So that is one thing. And then there's advantage of captive because in case you are dependent on discoms, then there's a possibility of load. So all these things you can actually that is avoid. So we have to look at this Electricity Act of 2003 and this electricity policy of 2005. So,
sorry to interrupt you, Mr. Ravikant. You are not audible, or your audio is very low right now.
This is the way one can really bring down the tariff for the industry, and this is going to be beneficial. That is for sustenance of the industry and profitability of the industry. Now there are some issues which would be there, as I told you, that is with respect to the renewable power. Like in the night, you are not going to get it. So at that time, you'll have to be dependent on the grid. The advantage also is that with respect to the consumption pattern, how you are going to use the power, you will have a lot of leverage in respect of that. Further, I would like to tell that there is something what is known as a group captive power plant. I don't know whether people must be aware of that. In a group captive power plant, what one can do, some 4 or 5 industries or maybe more or maybe slightly less, they can join hands and then have a captive power plant at a particular location to be developed by a developer. And the maintenance of that particular asset is going to be by the developer. That is another entity. And however, there is going to be participation of all the stakeholders with respect to the plant users. So in that particular case, you are not paying to the discom, you are paying to the developer. And when you are doing this to the developer, it's not that the entire equity is being put by the developer. It is all the companies are going to put in some part of equity, which as per the Electricity Policy Act has to be minimum 26%. So the balance 74% will be put by the developer, and the other participants are going to be shareholders in respect of that. So in that particular process, they have the provision that they are also part owners of it. And since they do not have the expertise of maintenance, the maintenance can be done by the developer himself. So this advantage is there. And then as for the policy again, in case there is a group captive power plant, necessarily 51% of the power has to be consumed. So these are some regulations which are there, and one has to keep it in mind. 51% of the power plants, it can be distributed with respect to the shareholding or what as per the requirement. PPA can be signed, and based on that, it can be ensured that 51% is going to be used, and the balance it can be let off to the grid as well. So maybe at a higher rate as a merchant power. So for this, there is going to be what is known as a special purpose vehicle, and as against that, one can join hands and carry out such a transaction. So this is going to be very, very beneficial. I'll just touch upon with respect to the prices. Now, these days, the prices with respect to the solar power has come down drastically. It is much lower than the thermal power. The thermal power may be around 4 rupees per unit or 5 rupees per unit. And out here in the solar, earlier, way back in something like 2011-12, it used to be more than 10 rupees per unit, but now it has come down as low as 2.5 to 3 rupees per unit. So there's significant advantage with respect to going in for the solar captive, and there's a lot of technology innovations which are happening. The capacity of the panels which are coming in, earlier it used to be around 125 watt peak, now it is something close to 440 watt peak and more, and people are now talking about 500 watt peak plus. So there's significant advantage. In such a case, the land use also with respect to the megawatt power will get reduced, and the cost of the modules, the way it is coming down, so there's going to be definite advantage. And already the prices are low, it can come further down. And with respect to the financing, there are not many ways of financing these days, as Dr. Gon Chaudhary and everybody has already commented. Now, there are commercial banks which are there, like SBI, IREDA, Yes Bank, and IDFC. And in addition to that, even the World Bank, they also give to IREDA. So they give the loans to IREDA at a very nominal rate of interest, which may be around 2%. And IREDA in turn gives the money to the banks so that the banks can loan it to the investors. And again, it is going to be slightly less. So the financing these days is not a problem. And further to that, the government policies earlier were having what is known as accelerated depreciation of the equipment. So for that, the taxation benefit is going to be there for the developers. And then there is a generation-based incentive. So the incentives with respect to the generation which you are doing. And further to that, in case in case you want to go in for the energy storage, you are having more power and you want to store it. So there's a possibility of viability gap funding, in the sense that in case you have to put in all the money, then it won't be workable, since batteries are very, very expensive. So there is a policy with respect to viability gap funding, and one can really look into that. So these are my few views which I wanted to share. So since the time is limited, I would really thank the panelists and the sponsors for giving me an opportunity to share my views with respect to captive power plant. And I hope that this journey of such a seminar is going to be very fruitful to all the participants. Thank you very much.
Thank you, Mr. Ravikant, for your excellent speech. Now our next speaker is Mr. S.K. Gupta. Mr. Gupta is a Managing Director of Crane Manufacturing India Private Limited and Crane Solar. Over to Mr. Gupta, please. Mr. Gupta, unmute. Yes, you can continue.
Yeah,
hello.
Good afternoon, everybody. First of all, let me congratulate my friend Amitav for his good association with this solar, and no word to him. I congratulate him again. Solar power in India is a fast developing industry. The great thing about solar power is that it's a technology, not a fuel. Now, when we say, as mentioned by Dr. Gan Chaudhary, country's solar capacity should have been more than 175 gigawatt or whatnot. But we could not achieve what we expected or what we targeted due to lack of awareness. Here I want to highlight something more on awareness of the system. I give my example. I have two factories at Ambernath, one of the suburb of Mumbai, and dealing with material handling equipment, EOT cranes and all that. Right from beginning, since 2010, then the system started coming up solar. Earlier, nobody was aware of the solar. I have that very passionate about solar power. In the year 2015, January, my friend Amitav came to Mumbai and we had a little discussion. And at the same time, he suggested me to go for solar. Since I was already passionate with the solar, it clicked me and both of us discussed in detail. I did identify an engineer, IITian from Mumbai, expert on solar, appointed him, engaged him, and he started 60 kilowatt solar system on our both unit factories. Since then, we never looked back. And what I found, later on we registered our company in the name Crane Solar Solutions with MNRE, Ministry of Renewable Energy, Government of India, and as an appellant agency for 5 megawatt solar power. We have installed later on number of units generating more than 500 kilowatts, which may not be very big when we compare with gigawatt and megawatt, but just as an entrepreneur, I wanted to develop this system and we did it. Initially, you may be aware that there was a huge subsidy from central government, like income tax benefit and also subsidy to individual consumers. However, due to lack of support from state authorities, the subsidy part is almost vanished. But for industry, even today, it is most beneficial by way of 100% depreciation in the first 2 years, thereby getting direct benefit of income tax. Economics, let me tell you why this is good and economic. Presently, I little bit disagree with Dr. Ghani Chaudhary. He said 3 to 4 crore per megawatt. And Mr. Adani also mentioned it's between 4 to 5 crore. So anyway, if it is even 5 crore per megawatt, number of units generated per month is approximate 100 to 110 per kilowatt. Cost is covered within 4 to 5 years, depending upon the tariff of the electricity in your area. So once it is balanced, life of solar is 25 years. So balance 20 years, you get back approximate 20 times of your investment, free of cost. There are endless advantages against nil disadvantage. Number one, financial advantage I explained to you about. The biggest advantage, another big advantage is a green, eco-friendly power. With our 60 kilowatts rooftop solar system, we have saved more than 100 tons of carbon in the last 5 years. So this is something which is, environmentally friendly. And last is helping the concept of one country, one grid, our Prime Minister. Here again, I would like to give my own example. We installed 60 kilowatt power, as mentioned, February. I could get back my total investment within 4 years, saving approximate 10 lakhs per year, which will continue for next 20 years now. Another cash benefit of, so total cash benefit works out to be about 2 crore. At an investment of 45 lakhs in 2015, I have already repaid and I am enjoying approximate 10 lakhs per year the revenue from electricity installed by me. Friends, today looking to the current energy requirement in India, solar power has inherent advantage of being absolutely effluent free. It does not require any maintenance and this is an assured green power. So if our industry take note of it, for example, I explained there is no end of success. My final submission is that we all, including state government, must put all out effort to promote solar power to get full benefit of natural resources and help country to reduce pollution. I quote, own your sun, be a solar power user. Thank you very much.
Thank you, Mr. Gupta, for your speech. Now I request Dr. N.R. Mandal, Dr. Nitish Ranjan Mandal to start his lecture on Dr. Mandal was the ex-professor and head of the Department of Ocean Engineering and Naval Architecture, IIT Kharagpur. Over to Dr. Mandal. Please continue.
Thank you. Thank you very much, Mr. Banerjee. It's great to be here. And
It's my pleasure. Please continue.
Yeah, thank you. I must say one thing. It's all initiative of our Avidavada, Mr. Ghosh, evergreen and bubbling with energy and bubbling with ideas. What to do, how to contribute. We all senior citizens sitting here idling, not doing anything. That's his main topic. We should be doing something. So he is continuously inspiring people to whatever way you can contribute, and that's really great. I mean, that is how this webinar, because as in the introductory speech he has told that we had been doing some work on renewable energy sources, etc. But we wanted to have again a discussion through seminar, could not do so now through webinar. Okay, gentlemen, good discussions are going on, and let me honestly confess that my specialization or my area of interest is altogether different. That is from the academic side. I'm a man of purely construction, large-scale construction, shipbuilding. But of course, I must also say that renewable energy is my passion. That one thing is my passion. Though it does not fall in line with my expertise, but I do take serious interest on this. And in that context only, Amitabh told me that he also participate and say something. Truly speaking, I being not an expert, I cannot give any expert this thing, but what I have observed, because of my passion, I worked on solar thermal systems. What means solar? I mean, here we are talking about only electrical power, of course, but solar energy you can also use as a heat power for the thermal systems. I remember in my institute, my room used to be at the second floor. So in summer, it used to get very hot. Those days, there was no AC easily available for the faculty people, right? So from that time onwards, I started thinking in terms of solar power using for air conditioning. So one area is, I mean, well, it's a question of energy. Like in the beginning, I think so. It started with probably Niranjan talked about, or maybe Amitabh, that energy is the, I mean, energy requirement. It's ever-growing requirement for mankind everywhere. So energy in the form of electrical power is the most convenient form of energy, which can be very easily, conveniently used to your applications. And also other is energy directly, the solar energy in the form of heat energy, thermal energy, it can be used. Wave tidal energy, the so-called the mechanical energy, can be converted to again in the form of electrical energy and to be used. So here, solar energy, one part is electrical, another is thermal. So in the form of thermal energy, maybe, I mean, here we are talking about utilizing, maximizing the renewable energy sources to satisfy our requirement. So, for example, like solar thermal, solar air conditioning is one of the area which industry can look into. Though here it is renewable captive power, that is the theme. But I'm just touching upon that. The solar air conditioning, solar refrigeration can be thought of. That needs a huge requirement is there in the rural sector where the farm produce is there, which is to be in huge cold storages. They are stored, which is energy guzzling so-called sector where one can think of that. And while coming back to this again, captive power plant for cost-effective application of foundry, heavy engineering industry, etc. This has already been told by Dr. Gonchoudhury that already he has highlighted the applications of rooftop installations. True. And also it has been probably mentioned by Mr. Ravikant that rooftop applications are good, but not much space is available. So eventually what happens is, of course, we'll have to think of all the possible places available: rooftop, ground, floating. Now, like rooftop application I have seen in the Adani's, the Dhamra port. Probably Mr. Ravikant must be knowing, in the Dhamra port, they have a warehouse which is roughly half a kilometer long, huge warehouse. The entire top has been put with solar panels, covered with solar panels. So that is how, I mean, wherever space is available, the rooftop is one of the most I mean, effective for the factories, for the plants, to be used for solar power generation. And wherever there is a water body, also for floating. But the question comes whether, I mean, we'll have to also look into this. In water body, making a floating solar is no different than having it in the rooftop. It's only you'll have to mount it on floating devices, which is indirectly our area of what we have done. But whether to save one aspect of environmental concern. I'm not encroaching into other aspect of environmental concern. Floating solar panels, floating solar systems. It seems there are again issues with the aquatic life. It seems there are issues with aquatic life because I'm going to cover up the entire, I mean, not entire, but a huge part of the water mass within the city. Within the city, the water mass is the breathing areas of the city. So those things ought to be looked into. Anyway, I will not go into the details of what are the technologies involved and all that, but from the user point of view, I would say that what we can find that everybody talks about the solar system, solar power generation. Certainly, they are very lucrative, very efficient. I mean, things are becoming more and more efficient over the days, so to say, with the new technologies coming up for newer solar materials. But if that is so, why the pace of application of these solar systems are so slow? That is to be understood. Why? I mean, we know that it's a very good thing. It's very clean. It's very easy to implement. It is cost effective. Everything is positive. Like Mr. S.K. Gupta very nicely has pointed out that one thing is certainly awareness. Certainly, that is one thing is there. But now I believe enough awareness is there, but still the pace of implementation, the pace of growth is low. Why? Because we'll have to, here we are not falling short of any technology or any other aspect. Even investment, finance is available, technology available, but still we are falling short of our target. Target we have set, like I feel with the pace we are going, this target will remain theoretical. It will be a very pessimistic way of thinking that we will not be able to hit the target. But so what is holding us back? That needs to be figured out, and that needs to be solved. Then certainly we'll achieve that, achieve our goal. I think some small notes I have made here while listening. Well, one of the key, I mean, probably the key word for maximizing application is, of course, invention and investment. Invention and investment. But I find invention, well, it's going in its own pace globally, right? By invention here, I mean, of course, invention of newer solar materials with higher and higher efficiency of conversion, etc. And investment, as has been pointed out, that there are good investment opportunities, investment incentives are there. Everything is there, but still application is remaining little. I mean, not that much. To solve one small area, I think so Mr. Ravikant has pointed out. I think so Mr. Ravikant only pointed out that group captive power. When this we're talking about the industry, they switch over. I mean, here I would like to point out one thing. I mean, 100% switching over from the conventional power to the renewable power is a long way probably, but we'll have to go step by step. Certainly, we'll have to look into the maximizing of utilization of renewable power such that I can minimize the conventional power. Why? Because the simple reason of reducing carbon emission and reducing the carbon footprint and making the planet more habitable, etc., that we all know. So what to do? I mean, how to get the pace, make the pace faster of implementation of this renewable power, I'd say. Of the renewable power, of course, solar takes the major, probably takes the center because of its ease of application and ease of installation and more convenient, simply because of that. So one would be that group captive power. Group captive power. Do I have some time? Anyway, I'll be finishing in a couple of this thing. So that is one aspect. That means we'll have to look into we have to try to figure out what is holding us back. What are the bottlenecks in the process? Why we are unable to do it? And one of the aspect I think is holding us back is the availability of the so-called the basic thing. The basic thing is nothing but the solar panels, which will convert the solar irradiation into electricity. Availability in the sense of, that means what is the scale of manufacturing going on? How much we are manufacturing? What are the raw materials? Where from it is sourced? How it is processed? Whether we have enough capacity in that, or we are too much dependent on some other third party and we are unable to produce the required amount. That is also is there probably one of the things which is holding us back, possibly. And lastly, I would say it's not directly in line with the industry only, but in line with maximizing usage of renewable energy is to encourage each and every individual to go for renewable energy. Now, in the way of, well, utilizing wind energy and tidal or wave energy, those are even more fluctuating type of energy compared to solar energy. Solar energy is more stable than one can say in the context of India. So here, I mean, government policies, government incentives should be such that each and every household even can think of setting up 1, 2, 3 kilowatt power of solar installations for their own domestic use. Cumulative effect will be huge. Overall, in the concept of the, I mean, to those targets which have been set, there's so many gigawatt of installation, etc. This domestic installation, if it can be maximized, unfortunately, what I understand, I may be wrong, you may correct me, that in the entire country, we're talking about one country, one grid, but I find in one country there are 100 policies. Every state has its own policy. In some state, you can do net metering, domestic net metering. In some state, you cannot do. But I feel if you, well, it is that catch-22 situation. The DISCOMs think that if net metering is given, as if immediately all household will become self-sufficient with their own energy generation through solar, and DISCOMs will have, instead of earning money, they'll have to pay money to each and every individual. It's not like that. It's like I remember from Howrah station to Kolkata, this side, those days the launch services were not there. Launch services started much after, though everybody knew that would have been very convenient. Why it could not start? Because the bus lobby was so strong, they did not allow to make it happen. They thought if launch services start, the buses will go empty from Howrah station. Did it happen that way? Never it happened. Both are applying with full capacity. So I understood that this electricity, I mean the DISCOMs, they think that, or even the ministry, they think that if it is done, there will be huge loss. I do not know if that is so or not. So these are the areas we'll have to look into. We'll have to globally see that how we can maximize, how we can go on maximize the use of renewable sources of energy. And in this, we have focused more on the solar energy, of course. The other sources of renewable energy, they are still a long way to go, as my knowledge goes in the renewable of the wave or tidal energy. They are extremely expensive and they work in much more hazardous environment. There are many other aspects to be solved. There are only a few, prototype plants globally, people are doing it. We have worked quite some in that area also while I was there in the institute, but that is a long way. Solar, of course, it can do. So I'd like to conclude here. Thank you very much for giving me this opportunity. I am somewhat misfit probably in this, but these are my ideas I thought I would share with you all. Thank you very much.
Thank you, Dr. Mandal. Thanks for your unconventional lecture. And
yes,
it was our pleasure to have you in this seminar, in this webinar. And our next speaker is Mr. Devobroto De, who was the ex-ED of WBPDCL. Over to Mr. De.
Oh, thank you, Arnab. Actually, first I must pay my gratitude to Amitabh sir and Niranjan Shah sir for giving me an opportunity to say something in this seminar. Actually, I am also part and parcel of the seminar. Now, first, let me share very two important messages. One is during 2015, September 2015, Climate Change Summit, all the countries came together to reduce the emission, to save the planet from the carbon emission. And you will be happy to know that, rather you'll be surprised to know that the only country, I repeat, the only country, Germany. Germany has taken a very bold step by 25 years, that is 2015 to 2040. By 25 years, they will switch over 100% switch over from fossil power to renewable power. That is, in the year 2040, there will be no fossil power station in Germany. Are you aware of that? I don't think so. Now, next encouraging point for us is our India. On 28th April 2018, all the villages in India, actually, we are talking about the energy. We are talking about power. Actually, energy is the first and last word in our daily life. I again repeat, energy is the first and last word in our daily life. Actually, on 20th April 2018, all the villages in India, I repeat, all the villages in India, the total count is 5,97,464 villages were electrified by supplying energy from different part of the country. Now, let me quickly go through some data I got from CEA. And right now, up to September 2020, the total installed capacity is 373 gigawatt. You will be surprised that it is encouraging to note that out of 373 gigawatt, 89 gigawatt, I repeat, 89 gigawatt is from renewable sources. What are the renewable sources? Renewable sources are small hydro, biomass, waste to energy, solar power, and also wind power. Now, in these renewable sources, wind power has toppled solar power. Up to September 2020, wind power installation is around 38 gigawatt, whereas solar installation is about 36 gigawatt. Now, solar is actually not moving fast. In the 12th five-year plan, actually, Government of India has set a target of 100 gigawatt solar power by 2022. But till date, only 36 gigawatt could be achieved. Then you understand there is a shortfall of about, say, 74 gigawatt by 2022. I'm afraid whether it will be possible to achieve 100 gigawatt target by 2022. Our professor and very respected person, Dr. Gon Chaudhary, again told that in his speech that by 2030 we will achieve 450 gigawatt energy from renewable sources. Actually, it is really how it will be possible that I can understand. Now, let me focus on two main issues. One is awareness of the entrepreneur for shifting from captive power to solar power, solar PV, or maybe you can say wind power, or you can say small hydro, or that is renewable source. What my boss, Mr. Enza, told in his speech about stable power. Yes, it is very important. Stable power. Stable power is required everywhere. And I must say, so far as solar is concerned, solar is not stable. So solar is only available when there is sunshine. And again, suppose there is a very good sunshine and one heavy cloud has come, heavy big vast cloud has come, then solar power will go away. That is a very important point, very important aspect, which is to be looked into, and how we can balance, how we can actually adjust this non-availability of solar sunshine, and also availability of conventional power with solar power. And definitely, if all the entrepreneurs of the steel, foundry, heavy industries, someone or some gentleman told about the cement industry, they require maybe huge power from 5 megawatt to 25 megawatt. And if they actually switch over from fossil power to solar power, or maybe some other say option of the renewable energy, from small hydro, from wind power, and then in a phased manner, definitely not one night, but in a phased manner it should be done. And that will be very, very helpful, because right now they have to pay perhaps rupees 7 per unit for the consumption of electricity. Another information, in the year 2000, I was given an opportunity for the evaluation of 1 megawatt solar power that are in.
Sorry for the inconvenience. I think we have
I found that
really
the
low
per
connectivity.
megawatt cost was around 13 crore per megawatt. And what Dr. Ganchodi told today, per megawatt cost has come down to 4 crore per megawatt. Huge actually reduction of per megawatt installation cost by just 16 years, 2004 and 16 years. So it is very encouraging, and already Dr. Ganchodi has pointed out there are so many ways and means by which solar power can be brought by wheeling. And one important aspect, one of my friends was telling me, why they don't look for BOOT, build, operate, own, operate, and transfer. Why they don't for BOOT? If they go for BOOT, then also they need to actually, their cash flow from their own pocket will be less. And after, suppose, say 10 years or 15 years, when they actually, it will be transferred from the developer to the owner, then another 15 years, they can enjoy the actually entire power with zero cost. That is one point I can add. And one more point I'd like to mention, that in September, it is also CA information. In September 2020, there was zero capacity addition. I repeat, in the month of September 2020, there was zero capacity addition, out of which there was 100 megawatt actually deinstalled, that is of Navy lignite, 2 into 500 megawatt unit number 5 and 6 was deinstalled in the year September, in the month September 2020. Then actually September 2020 is totally zero capacity addition, and also 100 megawatt has been deinstalled. Now, if I go through demand and availability, the figure of September shows the demand was in September 2020, the demand was 112 gigawatt, whereas the availability was 112 gigawatt. Only shortfall was 0.1%, and peak demand was 176.9 million unit, megawatt, and peak met, that is demand met, was 176.6 gigawatt, and the shortfall was 0.2%. Now, this is the fact and figure which I can tell you, and again I will say the endeavor made by GBS is a great, very great actually move in the solar power sector, and this should go on, this should go on, and this should go on. Okay, thank you very much. Bye.
Thank you, Mr. Dey, for your interesting facts and figures. It was very useful for the participants to note the figures and facts. Now, our next speaker is Mr. Amitabh Ghosh, Director, GBS Energy Private Limited. He will start his speech.
Okay, gentlemen, I will take few minutes and for few points. See, everything is very fine, but nothing much is happening. There's a big difference between the target and actual. Now, what is the reason? We must try to find out. I have few points which I thought I must share. The first point is the distribution company, who are mostly fed by fossil fuel power. They feel threatened. They feel that if they support solar power, then their revenue will go down. This has been mentioned by very high officials in West Bengal government to me, that if I lose revenue, why should I support that? I do not have answer of that. That I will not allow renewable energy to happen because I will lose fossil fuel power. I have no answer on this. Another thing, if you want to make a power plant or rooftop power on industries, there are three parts. One is the statutory part, second is the financing part, and third is the technical part. For me, the technical is most easy. You know, if we have a particular capacity, it can be done. But financing is a problem, and more problem is the statutory part. Statutory from DISCOM, and if you go for wheeling, then the transmission agency. And so much so, I have particular news. I will tell you the name also. Texmaco has a 3 megawatt hydropower plant, and they have a furnace. So they wanted to use the wheeling, and they found finally through wheeling, the figure is coming very near to their actual figure of what they are getting from the grid. So the case is that the government, all these bodies have to come together. If you have a particular mission, this is a renewable energy mission we are talking. See, if all others are not coming, and everybody, particularly fossil fuel, I mean, I can tell you CSC and WSCTCL, they are, you know, in front, they cannot tell anything because it's a government policy. But from their heart, no. So how it will happen? And that is why such a huge difference between the planning and actual. And this will continue. This will continue. Second point I want to present, which is important. See, solar is like mobile. It is ever changing, ever changing. So the one point we are telling that 25 years life. 25 years is a long time, particularly for industry, electronic industry like solar is like mobile. Every 2 years, we change our mobile. Even that mobile is very good. We change that. So it will happen also. Solar also, and I'll tell you, 2 meter by 1 meter solar panel. Initially, it started with 200 watt, then 250, then 300, then 400. Now, China, they are trying with 1000 watt in the same area. So the technology is changing very fast. One has to think. My idea for the financing, the owners should do their own financing with the help of the bank, but they should do it in phases. It is possible. You don't have to do totally in one time, because but you do one time and then you find the technology has changed. Like we change our television, we change our PC also, everything we change very fast. So that point, I think one has to take care. This is there. With this, I thank you very much, and my colleague Mr. Subir Ghosh will give a vote of thanks, and we'll take queries also from different people. Or no?
Thank you, Mr. Ghosh. Now we are open for the question answer session. So Amit, you start if anybody is willing to ask any question.
Yeah, thank you. I would just request all the attendees to kindly raise their hands, whoever wish to query any of our panelists. We will put you on the audio, and then you can ask your question, or else we will take up questions from Q&A section one after another.
Yeah.
So yeah, once the attendees are there, before that, let me only ask a quick question to Mr. Pritish. It's like I have heard like you are saying something about a carbon CO2 while generating steel. So I have a quick question, which a very generic question from out of the steel industry. I've heard a lot about carbon footprints. So is it like during this current period of steel manufacturing, you can also monitor how much carbon footprint has been generated while producing this amount of steel? If this is possible, yeah, then we can at least level that particular steel manufacturing industries, and then we can at least see which manufacturer is generating how much carbon footprint in the ecozone.
Yeah, that is, it is very much possible. That's what I said. Like these days, if you see the total carbon footprint of the world, say 8% of the footprint is by steel industry only. Some industries are very efficient. They may have it like 1.8 or some cases little low. Then, per ton of, steel, they produce 1.8 carbon dioxide, and some produce as high as 2.5, 2.6 also. So that is the range I can say. But like even if you hold it at 1.8 or 1.7, suppose increase thermal efficiency, then also you are not reducing the footprint that high, because the steel is being consumed, and it is the demand is growing and growing.
Correct.
Your footprint by 2050, people say, if they all other industries are also trying to do their best how to reduce the carbon footprint, which we are today at 7-8%. By 2050, if we stick on to the one what we are doing right now, it will be as high as even 33%. That is from 3% to go to 30%. That is the reason why we are thinking of going to a different technology, like instead of reducing carbon, to reduce by hydrogen, the use of hydrogen. Other thing is, if you see the arc furnace route means that is electric route. That means you take a scrap. Instead of going for blast furnace, you take scrap, melt it, or you take DRI and melt it. That melting is also, it's a energy intensive. But if you do the melting, through arc furnaces or steel furnaces, or electric furnaces, you generate much less carbon, say around 20% of the blast furnace route. But if that energy which is like used for arc furnace, if that is also from biomass, is from carbon, and then you are doing the same. You are just changing the one. So we are not solving. That is the reason why I say, I just briefly mentioned, because time was short. I briefly mentioned you have a technology that is like, instead of reducing by carbon, you reduce by hydrogen. Other thing is you do it at hydrogen, you do that also. If you do electrolysis by coal-fired power, thermal power, you are not solving the problem. That has to be done by renewable one.
Yeah,
so that is the big thing. What Mr. Ghosh mentioned at the end of it, the government is now thinking, I lose that discom power, I lose that one. So that is a very wrong thing. Thinking is completely very, very wrong. Unless otherwise, for any big change, this sort of a change, the policy has to be there, and it not only to be there, it should be incentivized. See, if I was attending an international seminar, there are people who say, suppose in Europe, today, if you go and you ask for a finance for a thermal power plant, you are not getting any finance. There is no power thermal financing there in Europe. And gradually it will come to our country. And it may gradually come to even steel sector also. So you should be very careful. That the renewable energy, what people are talking about, you have to first save the world to, human mankind to be there. That's the reason many places in the world, the youngsters are coming out and they're demonstrating against the big industries, because it's so much. They said that you're killing our plant, you're killing our planet. So therefore, it is very important that we go and, put more money, investment, reinvent it, and policies, the government policy has to be there. It is to be supported and to be incentivized.
Yeah, definitely.
Yeah.
Thanks a lot. Okay, I can see Mr. Prashun Chakraborty. Okay,
I have seen one. I have seen one question from Mr. Lalit Tiwari. How the actually solar cell could be brought from China? It can easily be done. You do it FOB Taiwan, then it can be done. Again, I repeat, you can do it from FOB Taiwan, not from China. Maybe the product is from China, but you actually import it FOB Taiwan. Then it can be resolved. The problem can be solved.
Okay. Thank you, Mr. Devutta. I can see Prasun Chakraborty has raised his hand. Mr. Prasun, I'm just allowing you to unmute yourself. You can please unmute yourself and ask your question. And please, while asking, before asking, just let us know to whom you're asking.
Yes, actually, I want to say one thing is that all power plants, thermal power plants, particularly, as I know, because I am initially I tell that I was director with Renewable Power Development Corporation. So we dealt with mainly thermal power during our service life. So about thermal power station, I say that DISCOM has got one problem to purchase renewable power, and to replace the conventional power by renewable power totally, because all the thermal power plants at the time of installation, they have to make a PPA, power purchase agreement with the installing authority. And say WBDCL has to make PPA with WDIC-DCL, distribution company, for 15 years or 20 years, how much power they will purchase. So even all the private thermal power stations, they have also installed based on the PPA made with the DISCOMs. So that much power has to be taken by the DISCOM. Thermal power has to be taken by DISCOM. So they cannot, unless and until that 20 years or 15 years period is expired, but it cannot be replaced by renewable power. That is one thing. And another thing, nobody has told about so much of, say, 175 gigawatt or 450 by 2030. So how about the storage of the renewable power so that it can be supplied 24/7 reliability? That is the two things actually I want to mention. Without PPA, no thermal power plant can be installed. So they have to agree with the 20 years or 15 years supply of thermal power. That is the thing I would like to mention.
Anyone from the panelists would like to take up this question? Mr. Devabrata, can you please unmute yourself?
Okay. I can share my. I can share my views. Yes. Okay.
Can I just share?
You can start, and then after that, Mr. Devabrata will take this.
No. Dr. Gon Chaudhary is the right person.
That's what I'm saying. Mr. Gon should start, and then you can take it.
No. One point, this storage, lot of research activities are going on. I do agree that storage is absolutely essential for 450 megawatt or 175 gigawatt level. Lot of research activities are going on. In fact, some power plants with storage, are coming up in the country, 3 megawatt, 5 megawatt level storage. And some power plants are also coming up, pump storage power plant, solar pump storage power plant. That is also one new idea. It is also coming up. A large power plant has been conceived, in a pump storage scheme. In fact, in Purulia, it was suggested, Purulia pump storage scheme, phase 2, it was suggested that it will be integrated with solar power. Pumping will be done by the solar, and that is how the storage will be done. In Australia, 100 megawatt storage based solar power plant has been already constructed and commissioned and connected to the grid. Now, the other point is e-vehicle, electric vehicle. They do have their own, batteries. And if you can charge if you have a solar power and if you charge the e-vehicles from the solar power, then automatically, the charging is, you are getting the storage. So e-vehicle, since it is coming in a very big way, so solar power and e-vehicle matches, each other, and it will be an automatic storage scheme. So that is how Government of India and globally, storage problem is being, handled. That is one. And for 450 megawatt and 175 gigawatt, a lot of regulations are there now. It is. I agree that in West Bengal, people are little bit. Discom is little bit hesitant to buy solar power, but it is not same thing everywhere. In Karnataka, already 4,500 megawatt solar power has been installed and it is being sold. So, the regulations depend also on the policy of the government. So the government policy, we are all trying to motivate the government to make lucrative policy for the renewable power. Only through lucrative policy, by the government, then only solar power will come up. Otherwise, what will happen? The 175 gigawatt, out of that, I have mentioned 87,000 gigawatt, 87,000 megawatt has already been installed. So how it has been, out of that, the contribution of West Bengal is not even 100 megawatt. Why? Because the regulation, the policies are not very attractive. All the power plants are coming up in Karnataka, in Rajasthan, in Gujarat. So the regulation and the policy is very important so that the private sectors are attracted, and then only this type of thing will come up. So I do believe that 175 gigawatt renewable power is achievable, and it will be achieved by next 2 years time, because already we have achieved more than 50%, almost 87,000 megawatt already we have achieved, and rooftop solar power plants are coming up in a very big way. I am telling you, in a very big way. Countrywide, it is coming in a very big way. Even in West Bengal, you'll see in next 1 year time, rooftop power plant will, because in the regulation, they have allowed, previously it was not allowed, this domestic sector was not allowed for rooftop. Now, in the latest, regulation, draft regulation, of course, they have allowed the domestic sector to put up rooftop solar power plant under net metering mode. And the potential of domestic sector, rooftop solar power plant in West Bengal itself is 1,000 megawatts. So if the domestic sector comes up in a big way, then the target achievement may not be a problem. As I have mentioned, the policy and the regulation will dictate the achievement of the target. So I do believe now at least Government of West Bengal has created a new department for renewable energy, and that department that is a good thing, and with a separate minister. So that is a good indication, and I'm sure with that and with change of policy, the target of 175 gigawatt, the target of the state also will be achieved. Thank you very much.
That will be great, sir. I remember the way, when the computer came, the people protested here and there are strikes also. So it should not be in that way, like we are opposing the things, but the other way around, what Bengal thinks today, India thinks tomorrow, we always mention, but it is going other way around. Now other states are going up. So there is a time that we should put our, impress people so that, we follow the one which is required. But it's very much required, and government policies has to be there. Not only has to be there, it should be incentivized also for any new thing to come. Unless otherwise government put their, views and put their, full support, it does not come. Otherwise we lag behind. Thank you, sir.
Yeah, I definitely agree with Mr. Pritish, so that government should help, so that guys from Bengal should stay in Bengal and work. They don't have to leave Bengal and then work.
Actually, political will is the most important thing.
Yeah, definitely.
Without that, nothing happens. Nowhere.
But actually, the question was about the PPA. Actually, the power station before 2017. The power station which were commissioned before 1st January 2017, they do have PPA of 25 years with the DISCOM. What about that? What about that? That question was asked by Mr. P.K. Chakraborty. I think the PPA is to be recasted. I think it is to be recasted. The role of central government as well as state government should be there for the recast. It should not be like that. Some solution is to be sorted out. How they can give some comfort to the power companies or the generating stations where the PPA was done before 2017. That was the deadline. 1st January 2017, there are a lot of installation, and after 1st January 2017 also, and there are a lot of installation, but those installation are mostly supercritical or ultra supercritical unit. After 1st January 2017, actually MOEF and CA are giving clearance for only supercritical and ultra supercritical unit, not the small capacity unit, only for the reduction of actually carbon emission, to reduce the carbon emission. I requested the contributor to reply about the PPA.
About PPA, yes, PPA is to be signed only by the in the power producer, not the captive power plant. The captive power plant, if you put up the captive power plant in a captive mode only, that means you are not going to sell the power, then the PPA will be not required. PPA will be not required. So since our discussion is on captive, so PPA is required if you want to sell power to the grid, to the DISCOM. Then only question of PPA comes. Now the regulation says here that net metering is allowed. Net metering is allowed, and all the industries here, those who have installed the rooftop or land-based solar power plant, they have only taken advantage of net metering. So in case of net metering, only NOC is required from the DISCOM, not the PPA. So PPA question is not coming for the rooftop solar power plant or the captive solar power plant. Okay.
Amit, next question, please.
Yeah, thank you, everyone. Now I can see Jayanta Chatterjee has raised his hand. Mr. Jayanta Chatterjee, I will allow you to speak right now. Kindly unmute your speaker. And before asking your question, kindly just direct like to whom you are asking. Mr. Jayanta, can you unmute yourself, please?
Can you do it from your side?
I can only grant access to unmute. The actual unmute should be done by the attendee. But anyway, if Mr. Jayanta Chatterjee is not here, we can take other attendees' question and we can revert back to Jayanta once he's back.
Next one.
So next one is Rajeshri Basu. I can see there are a few questions from Rajeshri Basu in the Q&A section as well.
You just read it.
Right now, I'm just unmuting Rajeshri Basu. Can you please ask your question?
Good evening, everyone. My question here is in regard to the solar generation, which is changed the model of and the paradigm in which the electrical power generation, distribution, transmission, and distribution happen throughout the world. Now, when we have the consumers themselves becoming micro generators, so it means that with net metering, they are able to export power from their residence or their plant if there is an excess to other places. So what it means is that there is a bidirectional flow of power. Earlier, it was only a flow of power from the generating stations to the consumers. Now, consumers now have become from consumers to prosumers, means producers and consumers both. So once they start producing, and with net metering, they're also exporting power back to the grid. Now, it has an implication on the entire grid stability as well as the protection and metering of the entire grid. So my question is to Dr. Ganchaudhuri. Sir, if you can just throw some highlight, what are the challenges here and what are the latest roadmap towards solving this bidirectional electrical energy flow, both from the power station to the prosumers and from the prosumers back to the grid and to the transmission system. So, and the grid stability in turn.
Yes, it is a good question. You see, that is the reason the DT level, at distribution transformer level, there is a limitation that this much of energy can be, we can allow this much of power, you know, from solar, rooftop solar, not 100%, in order to make the grid stability, because these are all bidirectional meter, net metering is there, they are importing power as well as exporting power. So that is generally 30% of the DT, that is distribution transformer, you know, the installed capacity of the rooftop solar power plant should be in that line. So the distribution companies internationally also, distribution companies keep all record, you know, that how much they are putting up, how much they are allowing. Generally, as per regulation, in our state, it is about 30%. Up to national level, it is about 30%. Some state, Delhi, it is 40%. So up to 30 to 40%, you know, rooftop solars you can install under a distribution transformer. So that is how you are protecting the grid stability. And but net metering is allowed because net metering is most popular regulation. That is the reason. Otherwise, you know, you can go in gross metering term also, but in gross metering term, you know, same thing will happen. More power will go to the, more solar power will go to the grid in gross metering. In net metering, you know, you are first consuming your power, whatever you are generating, then balance you are exporting if you are surplus. But in gross metering mode, you know, the entire power you will be exporting to the grid. So up to now, net metering is the regulation here in West Bengal, and in net metering mode also we can't go beyond 30% of the DT capacity. So that is how we are, you know, the discoms are maintaining their grid stability.
Just a follow-up to this particular question.
Is it 30% of the installed capacity?
Of the DT capacity. DT capacity. That means if DT is 100 kVA transformer, then up to 30 kVA solar can be installed under that DT.
Oh, okay. Install capacity.
Follow-up question to this. I asked about that the protection. Now, what happens? The polarity of the voltage transformers and the current transformers, which are directly interfaced with the relays, the protection relays. Those, what is the impact on that when the power is flow is direction is reversed?
But that is protected. Hundreds of rooftop solar power plants are working. There is no problem in that. You see, the import-export meters are working. Net meters are working fine. And protection-wise, the inverter has got protection. The power conditioning unit. And all the protections are there, and they are running in West Bengal itself. Now about more than 12 megawatt of rooftop solar power plants are working, and all with net metering concept. The PCU is there, power conditioning unit, and all protections are there in the power conditioning unit. So there is no issue regarding protection. Only the issue is regarding grid stability. Grid stability issue is there, I agree. But protection, there is no problem. The inverter itself has got all type of protection.
Not even at the substation level.
No, at inverter level.
There's no issues on the substation level at all, because when the power is flowing back from the circuit breaker back to the bus bar and back to the source. So isn't it all the directional relays and all and overcurrent short circuit relays are getting impacted?
No. That type of systems are also working, you know, in Kharagpur, in Bagnan, that type of system, you know, 1 megawatt system pushing power to the substation, and then it is going in the reverse mode. So there is no problem. There is no problem. You can go for protection.
Sir, I can add to your reply. Actually, in power station, when the unit is under synchronization, or rather before synchronization, we take power from the grid, and after synchronization, we actually give power to the grid. If this system is already there, I think there is no problem with net metering.
Okay, so we should move ahead now. Thank you, Mr. Rajeshri Basu, for your question. The next one I am picking up is Mr. Jayanta Chatterjee once again. Mr. Jayanta Chatterjee, we are again trying to put you on the mic. Kindly unmute yourself and ask your question. And before asking, just say the name of the panelist you are directing the question to.
Can you hear me?
Yes, we can hear you.
Oh, it's a very interesting subject.
Just a moment, Mr. Jayanta Chatterjee. We have a echo feedback from your mic. Can you try to move your mic away from your speakers?
No, that is very interesting subject we discussed. But representing very high power intensive industries, solar power, I really don't know how much use it will be. But in this connection, I have one question.
Mr. Jayanta Chatterjee, just hold on for a second. I can see you have logged in with 2 different devices. I am just putting one devices out.
Okay.
No,
I have knocked out the other.
I have removed one of the device. Now kindly ask your question.
Yeah, actually, my question is very simple. There is not much of a research work going on in the storage technology with so many battery companies around here.
Yeah.
Unless and until we have a good storage technology, more and more you produce solar power, where you are going to keep it? Hello.
Yes, we can hear your question. Now, who will reply?
I think Dr. Conchudri is there. Dr. Conchudri can reply.
I have already told, I do agree, storage is a big question, and we can't go beyond certain level unless there is a good storage developed. So the point is, a lot of research works are going on batteries, different type of batteries. Lithium-ion batteries are now coming up in a big way. Lithium phosphate. Then, as I have mentioned, the pump storage scheme is also coming up. Even the with battery storage, Australia has commissioned 100 megawatt solar power plant. So all the research activities throughout the globe, research activities are going on. There are other type of storage also. Supercapacitor based storage of solar energy. Then compressed air based solar energy storage. That type of all research. Even in Germany, they have a power plant of 150 megawatt compressed air based solar power plant. Compressed air based compressed air. So this type of all solar thermal storage is also coming up. So storage research activities are going on throughout the world, but the storage research is little bit slow. We couldn't achieve so far miracle result. Battery is still the most popular storage device in the globe. So I do agree that storage is a big problem, and worldwide storage research activities are going on, and maybe it is expected maybe in next 5 years time the solar with storage system will come up in a proper manner, and that will be competitive. Cost wise, it is still expensive if storage is there. Without storage, solar is very cheap now, but with storage, solar is expensive. So all the research activities are going on so that the solar with storage, the cost comes down, which is now quite high. It is now 10 rupee, 11 rupee per kilowatt hour. So the cost will come down. Hopefully by next 5 years time, it has been targeted globally that with storage, solar power cost in Indian terms, it will be 4 rupees per kilowatt hour. So with storage. So that is there. Let us hope for the best.
Conchudri, I have one question. Can you tell us that what will be the price of 1 megawatt storage capacity of battery? Can you give us an idea?
1 megawatt storage capacity. That is battery storage?
Yeah, battery storage.
Well, battery storage is now, you can say it is quite high. It is about 50,000 rupee per kilowatt battery storage for 40 to 50,000. It depends on the capacity. If it is a large capacity, then cost is little bit less. 40,000 rupee per kilowatt basis. So it will be in terms of megawatt, it will be 4 crores per megawatt storage, almost same with the solar.
So then, if we want to use your solar power at night, then the tariff will be too high.
Yes, I'm telling you, 10 rupee with storage, the solar power cost is 10 to 11 rupee per kilowatt hour. Without storage, solar power cost is only 3 rupee to 4 rupee per kilowatt hour. So almost 3 times.
Oh.
And in that case, Purulia model is better.
Purulia model is better. A small, pump storage scheme we are setting up. In fact, we are setting up. I am involved in that project in Manipur. It is a 12 kilowatt project, pump storage scheme, where battery will be not there. solar power will pump, water to the upper reservoir, and from the upper reservoir, water will come through the it's a 12 kilowatt microidle through the microidle to the lower reservoir. Again, that will be a closed loop. Again, the solar power will pump out the water to the upper reservoir. After running the turbine, it will come to the lower reservoir. So it is some sort of closed loop, and there hopefully in case of megawatt scale storage, the cost will be much less than the battery. But still the pump storage scheme is still experimental. But hopefully in the whole world, a lot of pump storage schemes are coming up. Designs have been completed. Somewhere, execution has started. As I have mentioned, in Manipur project, we have almost completed 70% of the work, and it will be commissioned by next January or February. So this type of systems are also, one more project is coming up in Ranchi, this pump storage scheme, small, that is a 25 kilowatt pump storage scheme that is coming up in Ranchi. So similarly, if it is a pump storage scheme, then the cost will be about 8 rupee per kilowatt hour. But if it is a battery based scheme, then it is 11-12 rupee per kilowatt hour. So research activities are going on. Hopefully, the cost will be, at par with the conventional power, maybe in 5 years' time.
So West Bengal is a pioneer, sir.
West Bengal is a pioneer, yes. West Bengal, is pioneer also in solar power.
What Bengal thinks today, India thinks tomorrow.
Yes, first solar power plant, 2 megawatt capacity was installed in Asansol, Jamuria, in the year 2009. That was the first solar power plant in the country, grid connected, 2 megawatt scale. But after that, we couldn't keep that, speed. We just, Karnataka, Maharashtra, Gujarat, Rajasthan, they have gone much ahead.
Is that power plant is still under operation? This Asansol power plant?
Sorry, I couldn't follow.
The Asansol power plant at 2 megawatts.
Yeah, that is still operational. Yes, that is still operational, functioning.
Thank you, sir.
Thank you, Mr. Jayanta, for asking the question. I can see.
Last one. I think we should conclude. We were taking one more question.
Okay. There are a few questions from Q&A section. Should I read one of them and then?
Yes.
So
I have to leave now. If with your permission, can I leave now? I have another meeting.
Just one question. Okay, you can leave. You can leave.
Thank you very much. Thank you.
Okay.
The next question is from Mr. Vishnu Sarkar. He has written can the highway be used for setting up solar power plant? Has Digha the potential for wind power? For lowering CO2 emission, do you consider nuclear power plant having good potential? So there are basically 3 questions in one question. Can the highway be used for setting up solar power plant? Has Digha the potential for wind power? And the third one is for lowering CO2 emission, do you consider nuclear plant having good potential?
Maybe something I can add here?
Yes, please.
Yeah, I'll start with the last point, nuclear power, what you have said. You see, nuclear power, the proponents of nuclear power, they will say this is the most cleanest form of energy. Absolutely correct. There is no doubt about it. But the point remains that it is one of the most dangerous kind of energy, right? Like what Dr. Gaon Chaudhary mentioned, probably it was not mentioned that, or somebody else was talking about Germany. Germany has decided by 2025, I do not know whether they will stick to that. They were supposed, after the Fukushima disaster in Japan, they decided that by 2025, all nuclear power plants will be shut down, all in Germany, right? So nuclear power, the problem is, I mean, after the Fukushima disaster, that time it just so happened the very next day I could talk to one of the Japanese professor. He told me a very nice thing. He said, you see, there is something called disaster index. I mean, the probability of disaster taking place and the effect of it. If disaster takes place, what is the probability of disaster that can happen? And the effect of that. Immediately I told him that while we travel from Kharagpur to Kolkata, there is a Kolaghat power plant. If I presume a similar kind of disaster happening in Kolaghat power plant because of some tsunami or earthquake, what will be the effect of it? Effect will be probably some few hundreds. I mean, fatality could be in the scale of 100 only, right? And duration of that effect of that disaster will be probably a couple of months. I mean, not even a couple of months, because there is no spread of any other polluting, much polluting environment compared to a nuclear power. So that is one aspect. So nuclear, even if it is, you say it's clean, but if a disaster strikes, then you had it. It continues. And one we generally hide, we do not talk about nuclear waste. In thermal power plant, we talk about the fly ash waste, how to dump it, where to dispose it. Nuclear waste, it's a great issue. So what world is now doing, there is a project called ITER, International Thermonuclear Reactor. In Ahmedabad, our Institute of Plasma Research is a party to it. It's a multinational project going on that is based on not fission but fusion. Nuclear energy, what we talk about here is fission technology. That means disintegrating the atom and you get the energy, which is being done in Kalpakam or all nuclear power plants. People are trying to replicate the phenomena what is happening in sun, that by through the fusion you produce hydrogen, and after the end product, the waste of that, not waste, the end product is water again. So that is still a long way to go to become feasible to utilize that fusion technology, right? That is that. And something else he said, I forgot.
One thing I can add regarding nuclear power, I have some data that France is utilizing from nuclear power about 79% of their total demand. 79%. France.
Yes.
Ukraine, 46%. Sweden, 40%. Finland, 31%. South Korea, 29%. Spain, 20%. US, 19%. Germany, now 17%. Russia, 16%. And Canada, 14%. So all over world, nuclear power is still there.
Yes. Yeah, I'll tell you, nuclear power is there and will be there. Like we are talking a lot of things about power. I am one of the proponent that conventional, what do you call, fossil fuel, it's a long way, still long way to go. Long way to go. Why? Because of the convenience.
Because of stable grid stability.
And yes. I forgot to state that. Because of stable, good quality power you get.
For grid stability.
Non-conventional energy, the biggest drawback, the proponent non-conventional energy, they don't talk about it. I say, because I am not a non-conventional proponent, passion for it. I love it. But the main drawback is quality. Wind power, unstable. Tidal power, unstable. Ocean energy, unstable. Solar energy, unstable. Nothing is, there is reliability factor is near zero. You don't know when the sun will be there and when the cloud will come. The wind is flowing when it's, so these are the issues, very serious issue. To solve that, we said, it's difficult. But thing is, well, very good quality power, very good this thing, or disaster. I mean, the accident, effect of the accident is, we have seen Chernobyl, we have seen 3 Mile Island or something, we have seen Fukushima, maybe some more. So anyway.
But Dr. Wonder, you have to think about the environment. Actually,
yes.
environment is deteriorating thick and fast. The glaciers are melting. The sun actually, sea level is rising. Antarctica temperature is rising. We should think about environment. We should make the planet habitable for our grandchildren and great-grandchildren. That is the point.
Absolutely, fully agree. I am saying, what I'm saying is, I'm not saying that I'm shying away from this. That's why I have the passion. I do it.
All the Germany has already taken a long-term program. By 2040, 2040, there will be no fossil fuel power. No, zero. Germany has taken.
Absolutely.
In the 2015 climate change summit in Paris. After that, they have taken this long-term program. 2040, no fossil power.
We have also taken a long-term, short-term program. By 2022, we will produce some 100 gigawatt of power. Those, those are fine. Those are fine.
Only 36 gigawatt.
Yeah. Those are fine. What I mean to say is, Germany also has told they will shut down all the nuclear power plants.
Thank you for the discussion. We have to stop somewhere. Otherwise, we'll keep on continuing. So, Amit,
you better stop here.
Yeah. So I now request Mr. Subir Ranjan Ghosh to the vote of thanks to the participants, and then we'll.
It is endless. There is a fight between conventional
Over to
and
Mr.
non-conventional.
Ghosh. Over to Mr. Subir Ranjan Ghosh.
There is a fight, conventional and non-conventional fight.
I'm listening to the animated discussion.
Yeah, Mr. Ghosh.
Good evening to everybody on behalf of GBS Energy. I have given the pleasant task of closing the session, and probably closing a very animated discussion. Probably it could have continued offline as well. There is no end to it. You know, this year's US election has been greatly fought on this particular front. So we do not know what exactly is going on, what will happen after the US election, whether US will also convert to mostly to the green energy from the conventional energy, fracking and all that kind of thing. But anyway, it's a pleasant task, and I would thank everybody who participated in this seminar, the speakers, particularly those who have given their best on the new platform. We thank them all. And also all the participants, because we never probably expected that participants would be so interactive. Today, you know, GBS had been very active.
Please give the figure how many attendees are there.
There had been a maximum of 19 attendees at a point of time, if I remember correctly. Amit would be able to correct me.
You can always see in your computer.
I know, we had seen it. 19 attendees were there, plus about 9 panelists. And at any given point of the number. GBS, as has been said, that GBS was committed to propagate the cause and the urgent need of conversion to solar or any kind of renewable kind of energies from the conventional energies for the sake of the humanity. It's a long way, but we must all attempt. Let us not be too pessimistic about it, because continuously the development is taking place, and all over the world that there is a move to save the world. As we know, the natural disasters are coming one after the another. You can see what is happening to US by way of wildfire and one after the another hurricane at any of their coasts. India is no different. We have a vast country and it can continue. So since the last seminar that took place on 9th of August, we always thought to make a sequel to it. It was planned, it could not take place. So Mr. Ghosh was extremely passionate about having a seminar on this platform, and it was his devotion and passion that made it happen today. So I thank him. Probably he is the driving force behind this seminar. I thank all the speakers who took their time off and gave such an excellent presentation. It is a kind of validation to this kind of seminar that a person like Dr. Gaurav Chaudhary joined and took part such a long time apart from his excellent presentation. I also thank that Mr. Ravikant, because Adani Green Energy is today the prime mover of solar energy in the country. And our goal of fulfilling the commitment to the Paris Accord largely depends on them, because government has chosen them as the prime force. We wish them a grand success. We all thank for all other speakers like Mr. Shane, Dr. Mandal, Mr. Day, and for their presentation and taking part in the interaction. We definitely missed some of the scheduled speakers and who had their actual personal kind of engagement, which made them to take off from this seminar. Otherwise, they were personally extremely interested in participation. And last but not the least, I must thank Mr. Amit Das of Amitech, who probably handhold us and coached us from the very beginning till today, and took all our pressure with a smile. And I hope that though we are missing the ambience of a auditorium, and but still it is a new experience for, at least for me, and those who have participated in many kind of this webinar. We enjoyed it. I had a problem with my bandwidth. Occasionally it is failing me. I'm sorry for that, but we hope we'll have more such meeting in future, and still I believe that in someday, may not be very far off, we can again meet in an auditorium sequence where more interaction, warm meeting, and personal knowledge would be possible. And at this outset, I thank again, once and again, everybody who had participated, supported this seminar. And today, the last wish should always be to each other that we should stay safe, stay healthy, and meet again someday. Good night.
Thank you.
Right. Thank you.
Thank you very much. Thank you, everybody.
Just a quick one for all the attendees. We are sorry for the question answers which were not being answered. I will pass the questions which were not being answered to Mr. Amitabh Ghosh, so he can offline. He can send you email all the questions.
Yeah.
Thank you everyone. Thank you, Mr. Subirda, for such a nice words for us. Thank you.
Thank you.
Thank you.
Bye.
Bye.
Thank you. Bye-bye.
Bye.
Bye.